presented by Tahir Karaçete, and the paper is Artificial Intelligence-Based Concentrate Compressive Strength Reduction. And the floor is yours, please.
Can you hear me?
Yes.
I am starting. Hi everyone, welcome to presentation of artificial intelligence-based concrete compressive strength detection. I am Tahir Karaçete and I am studying civil engineering at Gaziantep University. I am an undergraduate student. We did this study together with Muhammed. He is an associate professor at Üniversitesi. He is electrical and electronics engineer. Introduction. What is the concrete? Concrete is composite material obtained by combining cement with aggregate and water. And it can also be added various additives according to desired. You can see here is a sample of concrete. Concrete is used.
Here's Tahir Karaçete. Could you check your presentation and screen?
Is there any problem?
Yeah, we see the same page only. Material. Okay, now it's okay.
Okay. Concrete is used in many construction due to the its advantages of concrete, such as buildings, roads, bridges, and tunnels. Concrete has many advantages. These are high compressive strength, easy workability, durable structure, and being more economical than the other construction material. What is the compressive strength? It is the highest pressure that concrete can withstand under actual load. How is detected? In order to determine the compressive strength of concrete, samples are taken from fresh concrete and waited until it hardened. You can see here there is a hardened concrete, and when the concrete reaches a certain age, its composite strength is determined with the help of press. It is compressive. It is hydraulic press. What are the disadvantages? This method creates a cost as the material is used and takes time depending on the age of concrete. Literature. When the literature was examined, some different methods were found. These are imaging processing techniques, ultrasonic sound wave propagation speed, and fuzzy logic. Their disadvantages are they are not in a structure that can be applied easily and quickly in the files. And technical material must be used. If you use imaging processes techniques, you have to have a POSO device. If you don't have, you can't use it. What is the aim of this study? The aim of this study is to develop an artificial intelligence-based system that can predict a concrete compressive strength in a short time without the creating cost. Material and method. The study was carried out according to the flow diagram steps in the figure, and the effect of the parameters on the concrete compressive strength was examined, and using the feature selection correlation number, such as algorithm, and the most effective ones were selected. After the feature selection, rule-based models were created with the help of the decision trees to estimate concrete compressive strength over the selected features. And data collection. The data set used in study was obtained from the UCI machine learning repository, and dataset contains a result of 10-30 different concrete compressive strength tests and 8 properties based on number of materials used in production of concrete and the age of concrete. This table shows the distribution of data in the dataset. I said 8 properties, and these are cement, blast furnace, fly ash, water, spare plasticizer, coarse aggregate, and fine aggregate. Last stage, data set is divided into the training and testing. You can see here 80% of the data set was used to train the model, and you can see here 20% test the created model. Feature selection. Feature selection is the process of selecting the subset in the dataset that best described in the dataset, and we use Spearman correlation coefficient. And you can see here the most effective parameters are three parameters are age, cement, and spare plasticizer. And the most ineffective material is fly ash. Decision trees method is preferred as machine learning algorithm because of it has many advantages. For example, high performance and easy implementation in embedded system. And you can see here two models. This is model 1. It is complex, and this is model 2. It is not complex and you can read. It is readable. In order to evaluate the performance of the developed models, 7 different criteria were used. These are average absolute percent error, root mean square deviation, mean absolute deviation, standard error, correlation number, explanatory coefficient, and mean square of error. This criteria, it is expected will be close to 0, and this criteria will be close to 1. Results. The dataset named the complete compressive strength was used in the study, and the parameters affecting the complete compressive strength were determined. Model 1 and Model 2, which are decision tree models, are treated by selecting features and have the greatest effect on the complete compressive strength. And the performance of the created models were evaluated over 7 criteria. Model 1. It was created based on the first selected. It was created based on the first selected. You can see here a number of features for feature person, 50%, and the last number of the feature was selected to make decision tree model more simple and readable. There is 4092, and we select these reasons. And performance evaluation of model 1 was made on 7 criteria. And I set correlation number 092, average absolute percent error here 1793, and standard error 681 here. And the other criteria you can see here, there are 7 criteria. Model 2, it was created based on 7 selected feature. Feature person 87.5, and model 2 is more straightforward and more readable than model 1. It is readable, it is not complex, and the performance evaluation results model 2, which is evaluated over 7 criteria. Correlation number 080, and average absolute percent error 37%, and standard error 979. Discussion and conclusion. Concrete edge cement amounts, spare plasticizer, and water amounts were found to be most effective. I said that, and it was observed the amount of fly ash was not very effective. Model 2 has less depth and better reality than Model 1. So Model 1 was more successful than Model 2. The study showed that the compressive range of concrete can be estimated with certain margins of error. based on the material and age of the concrete. The benefits of the system, it predicts predicts the compressive strength of concrete. With the feature selection algorithm, the parameters with a high effect on the concrete compressive strength were determined. I talk about it. The most effective three parameters are age, cement, star plasticizer, and it can predict the compressive strength of concrete that has not yet been produced. It is important, no test, no cost, and it is predicting concrete compressive strength with high SO7. This presentation is finished. Thank you for attention.
Thank you for your nice presentation. I see there is one question from Lucas, and it is possible through the application of meta-heuristic optimization algorithms in your system? Is it possible to the application of meta-heuristic optimization algorithm in your system? You can see question and answer question and answer.
Yes, it is possible.
Okay, thank you for your answer.
Thank you.
And if and we can move on to the next presentation. And